Okay, this slide will compare to you the detection limit for several elements depending on either you use flame atomization AAS or graphite furnace AAS. Okay, let us see on the first two columns. Okay, this is flame AAS. Okay, graphite furnace AAS. Okay, you see that the units used are ppb. For the same element arsenic, okay, if you use a flame AAS, the detection limit is 150 ppb or 0.15 ppm lah. Okay, whereas in graphite furnace, okay, the detection limit is 0.2 ppb or 0.00002 ppb, if I'm not mistaken. Okay, so the difference is at least 1000 times lower. Okay, the same thing for chromium, 3 ppb. This is 0.03 ppb. Okay, for example, if you want to run selenium, okay, 100, you can do with graphite furnace AAS, whereby it can be detected easily because detection limit is better. Why go back to the previous slides where where is it? Okay, why does the determination of arsenic is sensitive using graphite furnace AAS but not flame AAS? Because of those elements in graphite furnace being discussed just now. Okay, low sample volume, okay, and then it is atomized 95%, and then the residence time is longer. All those factors contribute to the sensitivity of arsenic analysis. Okay, now let us see how does the graphite furnace looks like in Perkin-Elmer AAS. Graphite AAS,
Agilent now offers a range of supplies for your Perkin-Elmer, ICP-MS, ICP-OES, and atomic absorption systems like the Pinnacle 900Z. This is an instructional video to help you achieve the best performance and productivity for your Perkin-Elmer atomic absorption systems. And I'm going to start off by showing you how to replace the graphite tubes.
Why replace graphite tube? Because
Before we replace
it is
the graphite tube,
getting
we need to
thinner
clear
and
the
thinner.
autosampler. Release the left and the right locking knobs and swing the autosampler away. Click the open-close furnace button in the furnace control window of the software. Then, swing the support lever to the side. Tilt the front contact housing downwards. Use the insertion removal tool to remove the graphite tube.
So the graphite tube is
Orient the
really
tube
small.
and verify that the side of the tube securing the platform is on the left-hand side of the furnace. Using the insertion removal tool, place the graphite tube to the rear contact. Carefully tilt the front contact housing up into the closed position. Swing the support lever underneath. Click the open-close furnace button in the furnace control window to secure the workhead. Swivel the furnace autosampler back into position and secure. Check the alignment, which I will show you next. This procedure checks that the autosampler tip is aligned with the injection hole. Click the Align tip in the furnace control window to bring up the Align autosampler tip wizard, and then select the Align the autosampler tip in the graphite tube. The autosampler arm is unlocked and the pipette tip is moved directly above the graphite tube. Use the depth control wheel to lower the pipette tip until it is just above the graphite tube. Continue lowering the tip and adjusting its position left and right, forward and backward until the pipette tip is positioned just inside the injection hole of the graphite tube. Use the Tube View window in the software to see the location of the tip inside the graphite tube. Use the depth knob to position the tip 1 or 2 millimeters above the platform. If you adjust too low, click back and try again. Click Finish to save the position. Care is required when developing a new furnace program or changing parameters from the default method.
Actually, this is the camera inside a tube.
Poor drying conditions can result in sample spattering inside the tube.
Drying is very important to be optimized, yeah? We want to dry the water out.
Drying phase using the furnace viewing camera or the dental mirror. If you see the sample boiling vigorously, change the furnace method. Increase the ramp time or the drying steps, or reduce the programmed temperatures. With the correct drying conditions, the sample will dry smoothly and evenly in the drying phase of the program. Release the autosampler by undoing the left and the right knob and swing the autosampler away. To remove the graphite tube, click the open close button in the furnace control window of the software. Remove the graphite tube. Insert the new graphite tube into the right hand side of the furnace contacts. With the flat side of the alignment tool facing left, insert the tool into the sample injection port and align the graphite tube. Click the open close button in the furnace control window to close the furnace. Remove the alignment tool and check the alignment of the furnace. Unlock the furnace by moving the locking lever to the left. Remove the vertical alignment cover. Rotate the horizontal alignment control in small increments to minimize the absorbance reading. Repeat the horizontal and vertical adjustments until the absorbance is minimized. Move the locking lever to the right to lock the furnace in place. Refit the vertical alignment cover. Swing the autosampler in place and lock it in. Check for the alignment and the dispensing height. This is covered in other sections of this video. Please see the other videos in the series for the use of Agilent supplies and maintenance of your PerkinElmer Optima ICP OES.
Okay. You see that okay. You see that the graphite tube is really is in comparison smaller as the burner size in flame AAS, right? Okay. So have you ever wondered why it can get very low detection limit even though the path length, the burner is smaller? Because the factors, okay, the few factors that I mentioned just now, it actually like override this small path length. Okay, it actually better to have 95% atomization, okay, as compared to the 10 cm burner used in AAS. Okay, the percentage of sensitivity enhancement in atomization, in better atomization is better in terms of reducing the detection limit. Means that we want low detection limit. Okay. Okay. Now let us discuss about the application of graphite furnace AAS for two kind of samples. Okay. One is solid, one is liquid. Remember, I always say that always follow the standard methods if available. Okay, in this case, these are the PSM work from your seniors, your super seniors. Okay, they analyze mercury. Sorry, is it mercury? No, they analyze arsenic in seafood. Okay, and other than seafood, you can do analysis with heavy metals analysis in poison as well. Okay, and then you can also do determination of trace element in water sample. Okay, because sometimes when you are dealing with well water, all those air perigi, you can get a lot of elements. Okay, especially in perigi, they have more arsenic. Okay. It is also used in quality control analysis in factories. Can also be used to analyze industrial discharge to comply to EPA. So graphite furnace AAS is like everywhere. Okay. For example, over here, the work done is determination of arsenic in cockles. You will see the sample preparation and sample analysis. Arsenic can be present in several form and of those several different forms, they will provide different toxicity. If you eat seafood regularly, you may see higher levels of arsenic inside your blood, higher than other food. Okay, this is the digestion method. Specifically, it is microwave digestion method. Okay, why digestion method is used to prepare a solid sample? Why don't we just put the cockle inside the graphite furnace, right? Remember, you always want to stick with standard method. Okay, standard method will say that you have to prepare sample. So you don't have any choice to use sample preparation suggested by standard method. Okay, there must be a reason we do sample preparation rather than put all those solid inside tube. Okay, most of the time it is actually to save the tube for being frequently changed, okay, because of the decomposition of the matrix and so on. Because as I said just now, tube is usually getting thinner and thinner upon usage. Okay, so in this standard method, the microwave digestion is used with hydrogen peroxide and nitric acid. Okay, put inside the respective like tubes for microwave digester, and then you just proceed with the instrument. Okay, after that, prepare and transfer the sample inside this Eppendorf tube, and then it will be subjected to graphite furnace. And in the previous video, you watched that the chemist said that we have like autosampler. So autosampler is very good to be used because it can speed up the analysis in routine monitoring. Okay, you see the tube is smaller, okay, because it need only small volume. Okay, this is the same procedure. You have to do calibration curve and so on. Okay, so in the conclusion in the PSM work is that they found certain amount of arsenic, but it is lower as compared to the Malaysia Food Act atau makanan. Okay, therefore if you consume cockle in moderate amount, it is good. Okay, rather than you eat a lot and then for a long time, your risk of health decrement is can be seen. And then we have determination of arsenic in wastewater using graphite furnace. Usually arsenic is found in wastewater from electronic manufacturer. Okay, in the production of wafer and electronic devices. Okay, so in order to comply with EPA or DOE, they have to do analysis lah. Okay, if they found a lot of arsenic, they have to treat the arsenic before letting it go to the river. If not, jadi macam kes Sungai Kim dengan dekat Selangor. Okay, so prepare the sample. Same liquid sample is relatively straightforward. No need to grind, homogenize, whatever. Then use microwave digestion as stated by standard method. Okay, the student found around nanogram per mil. Nanogram per mil is microgram per liter lah, ppb. Same okay, from 13 ppb to 26 ppb. Okay, in different amount of in different sample. Okay,